Hello, this is Mr. Wynn, and today's video will be the first part of the Algebra 2 final exam review for the first semester. So here are the topics. You can pause it if you can read it, but I'm not going to. So starting off is domain and range. Remember, for domain, you always ask yourself the question, how far left does the picture go? How far right does the picture go? So for this left picture, it goes left forever, so negative infinity. It goes right forever, also so infinity, or sometimes we say all real numbers. For the range, we ask the question, how low does the picture go? And then how high does the picture go? It goes down forever, so negative infinity, and goes up forever, positive infinity. So also all real numbers. So lines, diagonal lines are the best. They're always all reals for domain and range. For a quadratic, a parabola, we have the same question, domain, how far left, how far right? It goes left forever, because arrow points left. It goes right forever, arrow points right. So also all real numbers. But the range is different. How low? The lowest point is 2, the y, and it counts. And the highest it goes is infinity. Or them use other notation, y2. Since 2 is the first number, it has to be bigger than 2, so greater than or equal to. And the last one is a square root function. Same question though, how far left, how far right? It doesn't go left past 1, so 1's the leftmost. It goes right forever to infinity. So you could say x1, and since 1's first, it has to be greater than or equal to 1. Range, how low to how high? It goes down forever, negative infinity. The highest is 2.5. So close on 2.5. And the other notation, y 2.5. 2.5 is on the right side, so it has to be smaller than or equal, less than or equal to that. Same question, domain and range. However, we're finding domain range of the inverse of the graph shown below. So inverse means to flip. Basically, you flip your x and y. That also means you can flip your domain and range, because domain was x, range is y. So to tackle these problems, you're going to want to do the regular domain and range of the picture. So for this parabola, domain and range is all real numbers. It goes left forever, right forever. Range, it goes down forever, but it goes up to -2. So that's for this blue picture. However, I want the new picture. So for the new picture, all you do is you flip it, you reverse it. So the new domain would be negative infinity to -2, and the new range is all real numbers. Now, if you wanted to graph it, which you do not have to do, it is always the reflection across y equals x, that diagonal line. It would look something like this. Right, so that has a domain from negative infinity, left infinity to -2, and it goes down forever, up forever. All right, this one, same idea. We find the original domain and range. It goes left forever, all the way to 1.5 to the right. The range, it goes down forever, and it goes up to 2.5. However, that's of the picture graphed. We want the new one, the inverse. So you just flip it. So the new domain would be our old range, negative infinity to 2.5. And our new range is the old domain, negative infinity to 1.5. All right, make sure you can turn a triple system word problem. Just find the equation so you do not have to solve it. So every sentence is an equation. So the first family, the Johnson family, has 5 burgers, 4 hot dogs, 5 drinks, paying a total of $23.50. So that would be $5 times the price of burgers, so 5b, plus 4 times the price of hot dogs, plus 5 times the price of drinks, and the total was $23.50. The next one, the Hamilton family, 3 burgers, 2 hot dogs, 5 drinks, paid $15.50. So 3 burger plus 2 hot dogs plus 5 drinks, total price $15.50. And the last family, Guerreri family, 2 burgers, 1 hot dog, 2 drinks, $8.50. 2 burgers, 1 hot dogs, 2 drinks, $8.50. And that's it. All they want is you to set up the problem. Can you find the three equations? You do not have to solve it. However, you did want to solve it. Remember the steps in the calculator, just in case. On the calculator, you want to press second matrix, go to edit, pick one, 3 by 4, type the coefficients. So the first row are burgers, 5, 4, 5, 23, 50. Next one, 3, 2, 5, 15, 50. 2, 1, 2, 850. Second quit, second matrix, go to math, go up to double REF, put in your matrix, second math matrix, that, and there's our answer. So one burger costs $2.50, one hot dog costs $1.50, one drink costs $1. All right, here's the next one. School competition gives points based off of the medals the school earns. The first team has 5 gold, 8 silver, 3 bronze, total of 52 points. So that's the equation. So 5 gold plus 8 silver plus 3 bronze equals 52 points. The next one, Team B has 7 gold, 3 silver, 6 bronze, 50 points. And the last one, Team C has 2 golds, 6 silver, and 8 bronze, total of 36 points. Again, just set it up, don't solve. Make sure you can graph and shade. Y is greater than or equal to -5. That's linear, it's constant. Y is diagonal. Sorry, not diagonal, horizontal. 1, 2, 3, 4, 5. Here's the line. It's solid. I got a shade. I do a test point, 0, 0. I plug it in. 0 is greater than or equal to -5. That is true. So I shade with the test point above. All right, x is greater than or equal to 2. That's linear, constant. It is vertical. So go to x is 2. Solid line. I do a test point. I'll try 0, 0. 0 is bigger than or equal to 2. That's false. So I avoid the left side. I shade the right side. Now remember, we covered the overlap. So that top right rectangle where it's both blue and red. And the last one, this starts, instead of 0, 0, it starts up 8. So 1, 2, 3, 4, 5, 6, 7, 8. It is flipped and taller, but would be more accurate. So we're going to use this as a slope of -2. That means down 2 over 1. Down 2 over 1. It's rise over run. Down 2 over 1, down 2 over 1, down 2 over 1. Right. That's solid. Here's the graph. I do a test point. I'll try 0, 0. 0, 0 plus 8. 0 is smaller than or equal to 8. That is true. So I shade with the side 0, 0. I do not care about the left side, only the overlap. So I'd only shade this part. So we see that little triangle, that's the feasible region. That's where it's all 3 colors. It's green, blue, and red. Now they want the points, the vertices of that. So I need this point right here, which is 2, 4. This point right here, because that's the edge of my triangle, that is 2, -5. And this point, we know the y is -5. The x is actually in the middle, so 6.5. 2, 3, 4, 5, 6, 6.5. That's it. So here's our triangle. That's the feasible region, and the vertices are 2, 4, 2, -5, 6.5, -5. Here's another one. Y less than or equal to 6. That's the horizontal line, constant. I plug in 0, 0. 0 is less than or equal to 6. That's true. Shade with the test point. X less than or equal to 5. Constant, vertical line, up and down. I plug in 0, 0. 0 is less than or equal to 5. True, shade with the test point. I'll only do the overlap part, so I don't care about the top part. So in this bottom right, left triangle or rectangle, start at 2. Flipped, regular meaning diagonal. Slope -1, so down 1 over 1, down 1 over 1. All right. So I'm just trying to be accurate here. Up 1, left 1. And draw that, connect it. And it's solid. Be careful if it's solid or dotted, but these are solid. Test point 0, 0, 0, 0 plus 2. 0 is bigger than 2. That is false. So I void the bottom part. I'm going to show the top part. Makes us this triangle. So most of the time you'll see a triangle. We need that's the feasible region. We need the vertices. So we need that point, this point, and this point. All right, so that is left 1, 2, 3, 4, up 1, 2, 3, 4, 5, 6. Negative 4, comma 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 5, 6, and 5, negative 3. All right, which points outside the system? So all we're doing here is plugging in all the points into each equation, make sure it's always true. So I'm gonna try this first one. I plug it in. 8 is bigger than or equal to 2. That's true. 2 is smaller than 3. That's true. 8 plus 2, that's 10, is smaller than 8. That's false. Since that fails, that's wrong. So let me slash that. Now, it would take a long time to try that for all 4 answers. So what we'll do is we'll try the easiest one. So this looks easy to do. Y is bigger than X. I'll look at all the answers and see which one has Y that's not bigger than X. So 4 is bigger than 3, that's good. 2 is bigger than 5, that's false. So C is automatically out. If it fails one of them, it's not the answer. And 6 is bigger than 1, that's true. All right, this next one, X is smaller than 3, that's also easy to check. 3 is not smaller than 3, so B is out. 1 is smaller than 3, that's good. That's the last answer. Left, that's the answer, but we can check it. So 6 is bigger than or equal to 1, true. 1 is smaller than 3, true. 6 plus 1 is 7, smaller than 8, true. All 3 are true. So just plugging a test point to see if it's in the feasible region or not. All right. Transformations. Remember, this is where we say, did the graph go up, down, left, right? Is it taller, wider, or flipped or not? So make sure you use the correct vocabulary. So instead of saying up 5, I'd say shifted up 5. Instead of saying left 5, I'd say shifted left 5, or 5 units left. Instead of taller, we say vertically stretched by a factor of what the number is. Instead of wider, we say vertically compressed by a factor of what the number is. And then instead of saying flipped, upside down, we say reflected across the y-axis. So make sure you use these words and only those words. So explain what every number and sign does. So this plus 4, that makes it go up 4, or correctly it would be shift 4 units up. All right, this minus 2, that's inside the x, where it's opposite, that's actually right 2. So I say shift 2 units to the right. You can say shifted if you want to be precise. All right, this 5, it's bigger than 1, that makes it taller. But instead of saying taller, we say vertically stretched. Vertically stretched by a factor of 5. And that negative sign flips it. When saying flipped, upside down, we just say reflected across the y-axis. And that's it. It'll be multiple choice, so those words will be in the answer choice. Another one, same thing. Minus 5 would be down 5. Now, I don't write down 5. I say shifted 5 units down. This plus 3 is x, that means left 3. But you don't say left 3, you say shifted 3 units left. And this 1/2, that makes it wider. But you don't say that, you say vertically compressed by a factor of 1/2. Right, so there's what I say in class, and there's how you say it correctly. All right, and now I'll stop the video here. We'll do the next slide in the next part.